So here we have an ellipse and a hyperbola, and we're supposed to find out where they intersect. So what I'm going to do first is sketch a little graph of the situation. Basically I want to see, one, do they intersect at all? And two, how many places do they intersect? How many times do they intersect? So for the ellipse, in the x direction, you take the square root of this number, we would get plus or minus 4. So on the x-axis, -4, +4. In the y direction, take the square root of this number and get plus or minus 5. So go up by 5 and down by 5 on the y-axis. And then just draw a nice oval shape ellipse. Okay, on to the hyperbola. So with the hyperbola, you take the square root of this number, we'd get plus or minus 3. And then in the y direction, or up and down, take the square root of this, and that's going to be up by 2 and down by 2. And then, in order to get the asymptotes for the hyperbola, what you do is take what some people do is they just make a little box right here, a little rectangle. I just do it lightly in pencil because it's going to give us the guidelines of how to draw it, but it's not actually the hyperbola. And then for that little rectangle right there, you just connect the corners, or in other words, draw a diagonal, but make it a dotted line because that's going to be the asymptote. In other words, the hyperbola is going to get closer and closer to these dotted lines, but not actually touch them. And then the next thing to do is you look at the equation, and it is the x squared that's the positive one. So that means it's going to go left and right just like the x-axis does. And in fact, it's going to hit the x-axis right here. How about if we make the hyperbola a nice blue hyperbola? It's going to hit the x-axis right here at 3, and then it's just going to branch out closer and closer to those dotted lines. And then the other branch of it is over here. Alright, so there's our graphs of the two shapes, and you can see there's actually 4 places where they intersect. Here, 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 here. And the good thing is that the graph is symmetric. So if we find this one, then we just have to say, well, this one down here, the x value is going to be the same, but the y is just going to be negative. It'll be the same number for y, but it'll be negative. And then, for example, over here, whatever we get for x over here, because it's symmetric, it would be the same number for x over here, except it would be negative. So we really just have to find this one point, and then say plus or minus the x and plus or minus the y, which is naturally going to come from when we solve for x. You have to take plus or minus the square root of both sides anyway. So the next thing is, with this system of equations, we could use substitution or elimination. I think that I will use substitution. So in here, I'm going to solve for x squared. So leave x squared over 9 there. Take this thing and add it to the other side. It'll become positive y squared over 4 plus 1. And then in order to solve for x squared, multiply both sides by 9. So it would be 9y squared over 4 plus 9. And then, right now, we don't have to solve for x because this has x squared in it. And so all we have to do is replace x squared with what x squared is equal to. This thing right here. So then this equation would become x squared gets replaced with 9y squared over 4 plus 9. Now that is replacing that x squared right there. Everything else in the equation is still there, so the whole thing still over 16 plus another fraction, which is y squared over 25, is equal to 1. Well, it looks like a bit of a mess, but we could clean this up, for example, in here to clear the compound or complex fraction. All you need to do is take that denominator of 4 and multiply on the top and the bottom by 4. So on the top, when you When you distribute the 4 right here, these 4's would cancel, and it would leave 9y squared. You would have to distribute the 9 times 4 is 36. And then what about 4 times 16? Well, that's 64. All right, then we could even simplify this one by finding the least common denominator for a 25 and a 64, which is pretty easy to do because this is made up only of 2's, this is made up only of 5's, so they have nothing common. That means the least common denominator is going to be 64 times 25. Calculating that quickly in my head, 64 times 25 is 1600. So multiply both sides by 1600. So all three terms get multiplied by 1600. And then in here, 64 will divide into 1600 25 times because that's where the 1600 came from. So we would have 25 in parentheses 9y squared plus 36 plus over here 25 into 1600 will leave 64 y squared and then equals 1600. Look at that, we're almost done. Now just go ahead and distribute this 25. So 25 times 9, as we all know, is 225 y squared. And 25 times 36, hopefully you've got your 36's memorized, is 900. We're not even going to have to do the quadratic formula. All you need to do is subtract 900 from both sides and combine the y squares. So let's see, if you subtract 900, that's going to leave 700. And a 225 plus a 64 is 289 y squares. All right, now just divide. Y squared is equal to 700 divided by 289. And then we should get the decimal answer. So then take the square root of both sides. And this is the part where we put plus or minus the square root. So in here we'll get plus and minus the square root of 700 divided by 289 is 1.556. And then at this point I would take a look at the picture and see if this makes sense. So the y value for this red dot right here, if you go over, would have to be right here, a little bit below 2. So 1.556 definitely sounds reasonable. Then we need to find out x. So we need to take that number and substitute it in here. It doesn't really matter if you put the plus or the minus because it's going to be squared anyway. So we've got x squared is equal to 9, and then the 1.556 is squared over 4 plus 9. And then we would need to take the square root of all of that in order to solve for x. So let's go ahead and do that now. So the square root, so we're going to do this step. The square root of 9 parentheses 1.556 is squared. That's divided by 4. And then plus 9. And all of that is inside of the square root. So x is going to be plus or minus 3.801. And again, look and see if that makes sense. The red dot, according to this picture, has to be between 3 and 4. So 3.801 sounds good. The final thing, write it as an ordered pair. So x, here's a way you can write all 4 answers at the same time. You just say x is plus or minus 3.801. and y is plus or minus 1.556. And then that takes care of all 4 of those red dots.